Hello Tachyons, this is Kumar and welcome to the TachyLab. We are doing motion, forces and energy and this is lecture number 2 of physical quantities and measurement techniques. I hope you guys are ready. So here is our first topic, that is area. So what is area? Area is the surface covered by any 2D shape. For example, a cube, a square, a rectangle, a circle or triangle. So how much surface is covered? If I say this is first and this is the second figure. So out of 1 and 2, now you know that okay, second one is covering more surface. That means second has more area. Now for several shapes, we have different formulas. For example, if we have to find out the area of triangle, this is length and this is breadth, and if you simply multiply it, we'll get the area. For square, this is side and they both are equal. So it will be side cross side. What about area of triangle? This is the base. Half cross base into height. This is the height, the peak. How high the peak is. Half into base into height. Area of circle. So in case of circle, if you know the radius r here, and then you can use the formula pi r square and you will get your answer. Now comes the units, SI unit of area. Take any formula and let us say for rectangle. You know it is length into breadth. For any length, suppose even if this is length, you know you are going to tell okay if it is 2 meter, 5 meter or something. So its unit is meter. So for any length, it will be meter. So the SI unit will be meter square. Okay, so centimeter square, meter square, kilometer square, all of these are the units of area. Now comes the conversion. If I say 1 meter square, I can write as 1 meter into 1 meter. And in 1 meter, how many centimeters are there? So 1 meter is equals to 100 centimeter, and we can write 100 centimeter into 100 centimeter. So it will be 10 raised to power 4 centimeter square. So 1 meter square is 10 raised to power 4 centimeter square. And 1 centimeter square would be 10 raised to power minus 4 meter square. I hope this is clear. These conversions are very important. Similarly, you can do for millimeter square to centimeter square or millimeter square to meter square. Moving to the volume. Now, what is volume? Volume is the space occupied by an object. Now we are talking about 3D. That means we won't be talking about a circle. We'll be talking about a sphere. We'll be talking about a cube. We'll be talking about cuboid. We are talking about the 3D shapes now. These. I hope it is clear. So if this is the first figure and suppose this is the second one, and you know the second one takes more space, is occupying more space, right? So volume for this one would be more than the first one. And how you can calculate it? So for volume, we have length into breadth into height. So this is length, this is breadth, and this is height. And for cube, it will be side into side into side. And for cylinder, if this is the cylinder, this is the radius, and this is the height. So how we will be calculating it? Pi r square h. I hope this is clear. Now similarly, we can do the SI units for volume as well. Let us take the example of a cuboid. So for cuboid, you know it is length into breadth into height. Now every or any kind of length is measured in meter. So it would be meter into meter into meter. That means meter cube. Now let us see the conversion. Again, very important. So 1 meter cube we can write as 1 meter into 1 meter into 1 meter, which is basically 100 centimeter, 100 centimeter, 100 centimeter. Now it is 1, 2, 3, 4, 5, 6 zeros. So 10 raised to power 6 centimeter. How many centimeters? 3 centimeter cube. That means 1 meter cube is equals to 10 raised to power 6 centimeter cube. And similarly, we can write 1 centimeter cube is equals to 10 raised to power minus 6 meter cube. I hope this is clear. Similarly, you can do for millimeter cube to centimeter cube or millimeter cube to meter cube. I hope this method is clear. Now, how do we find out the volume of the liquid? Okay, we'll pour the liquid in a measuring cylinder and we'll know that, okay, if this is the measuring cylinder, so there are some markings here. So once you pour it, you'll get to know, okay, how much the level is, right? But whenever the liquid is poured, either it will be this way or it will be this way. Now, what is this called? This is called as meniscus. So for any liquid, most of the liquids like water, we will see the lower meniscus. This one will read this. Like this is the one, then this will be the level that we will be seeing. But when it comes to mercury, mercury curves in the opposite direction. So we will see the top, this one, when we are measuring it. And whenever we have to measure that the level, eyes should be here. It should not be here or here. No, you will get the wrong reading. Okay. So it will cause the error and we have to avoid it. So reading should always be taken at the eye level. I hope this is clear. Then comes the conversion whenever we're talking about the liquid, and usually we measure it in terms of liters. So we should know that, okay, 1000 centimeter cube is equals to 1 liter and 1 milliliter is equals to 1 centimeter cube. These conversions will help a lot. Then we have time. So yep, time's running out. Okay, unit of time. Time is basically, we know, right? We are measuring that, okay, how much time has passed. And how do we see it? We usually see it in seconds, in minutes, in hours, in days, in years, right? So what is the unit of the time? This is the SI unit, that is second. And how do we actually define it? A second is defined using energy changes in cesium atoms. We don't need to remember that. This is the main thing. And then how time is measured? There are several devices, right? And these several devices, they can use the regular or repeating oscillations like we see in the pendulum clocks. Uh, in older times, there used to be, those big clocks with the pendulum, which is swinging like this. So that's a pendulum clock. Traditional clocks also, like the balance wheel or the digital clocks, the quartz that uses a quartz crystal. Then we have choosing a timer. Now in some of the questions they actually ask that, okay, what kind of a timer should we use? Now it depends that on what precision you want the reading. Okay, so whenever you're doing an experiment, it's very important that you decide it. Okay, first is this stopwatch. Okay, so that will be measuring the period of a pendulum. It's best for that. Then we have millisecond timer. So millisecond, that means 10 raised to power minus 3. That means we are talking about very short time intervals here, right? Like measuring the speed of the sound. Then we have electronic timers. Electronic timers like microphones, photo gates, or mechanical switches. And we have ticker tape timers and data loggers. What for? Again, to record very short time intervals in motion experiments. Motion experiments is important. Sometimes they ask it and you can mention any one or two of them. I hope this is clear. Then we have improving accuracy. Now, how do we improve the accuracy of any experiment which is related to the time? First of all, we should measure longer time intervals. That will reduce the effect of the timing errors. Second, instead of taking, like for example, when we're talking about the pendulum, instead of taking very less oscillations, we should measure for more oscillations or several oscillations, and rather than just one. Then we should take a lot of readings, like we should repeat the experiment for like 2, 3, 4 times and then get the average. That will get us results which are better. Then how do we calculate the period? So the total time divided by the number of oscillations. How do we calculate the period? The total time taken like 10 seconds and number of oscillations were like 20. So it would be 10 divided by 20. Okay. Then for ticker tape timers, use several ticks rather than relying on single tick. So this is similar to the previous ones. If you are able to understand my way of teaching and you're liking it, do like the video and share it with your friends. The link for free notes is available in the description, and you can also contact us for one-to-one and small group classes. Now let us do the questions. Okay, so here is the first question. So it says calculate the area of triangle whose base is 8 centimeter and height is 12 centimeter. So how do we calculate it now? You should know the formula here. And what is the formula? Area of triangle is equals to half into base into height. So half into base is 8 and height is 12. So answer is 48 centimeter. So is the centimeter correct unit here? No, it is 8 centimeter into 12 centimeter. It will be centimeter square. So take care of the units very well. Usually students do this mistake and they write like 48 centimeter and then they end up losing their marks. Then comes next question. Now it says calculate the volume of a rectangular box, which is basically a cuboid, which is 30 centimeter long, 25 centimeter wide, and 15 centimeter high in cubic meters. That means meter cube. Okay, we have to calculate in meters, but see the units here. Units are given in centimeter. That means we need to convert it. Now either you convert all of them, okay, like 30 centimeter in meter, 20 centimeter in meter, 15 centimeter in meter, and then find the volume, or you can do is you can find the volume first and then apply the conversion. So let us write volume of rectangular box, that is length into breadth into height, which is 30 centimeter, 25 centimeter, 15 centimeter, and this comes out to be 11250 centimeter cube. Right now the answer is in centimeter cube, so it is incomplete right now because they are expecting us to give answer in meters. So in meter cube, what was the conversion? Conversion was multiply by 10 raised to power minus 6. So volume is equals to 11250 into 10 raised to power minus 6, which is 0.01125 meter cube. Now this is the final answer. This is the final answer and you will get full credit for this. Yes, moving to the next question. Now it says calculate the volume of a cylinder whose radius is 50 millimeters, height is 25 centimeters, and we have to calculate answer in meter cube. Okay, so for millimeters we haven't done, I did not show you the conversion, but yes, we'll do it now. Calculate the volume here. Now radius is given to be 50 millimeter, right? In 1 millimeter, okay, 1 centimeter we have 10 millimeters. That means 1 millimeter is equals to 1 by 10 centimeter. So it would be 50 into 1 by 10 centimeter, right? Which is 5 centimeter, but we have to, but we are already converting it. So let us just convert it into meters, all of the radius and the height, and then just calculate the volume. So now when it comes to 5 centimeter, now 1 meter is equals to 100 centimeters. So 1 centimeter is equals to 1 by 100 meter. So it would be 5 by 100 meter, which is 0.05 meters here. Then comes height. Height is given to be 25 centimeter, which is 25 by 100 meter, which is 0.25 meter. And what is the volume? What is the formula? Formula is pi r square h. So pi 3.14, 0.05 0.05 and height is 0.25. So volume comes out to be 0.001965 meter cube. Now the answer is in meter cube. Okay. I hope this question is clear. This was important because in this we are converting millimeters and then centimeters to another unit, that is meters. Moving to the next question. Okay, now see, it says the pages of a book are numbered 1 to 200 and each leaf is 0.10 millimeters thick. Okay, so pages are numbered 1 to 2. See, this is the page. So 1 will be numbered here and 2 will be numbered on the back side, right? That means two numbers, 1 and 2, but page is just 1, right? So 1 to 200. Number of pages, how many number of pages are there? It will be 100. And now it says one leaf is 0.10 millimeters. And how many pages are there? 100. So for 100, it would be 0.10 multiplied by 100, that is 10 millimeters. Now it says if the cover is 0.20 millimeters thick. So, but we have two covers, right? The upper one and the lower one. So for cover, it would be 2 into 0.20 millimeters, that is 0.40 millimeter. Now comes thickness of the book. So it would be the pages and the cover. The pages is 10 millimeters thick, and when it comes to cover, it is 0.40 millimeters thick. So when we add it, it is 10.40 millimeters thick. And in meters, how much it would be? 10.40 into 10 raised to power minus 3 meters. That means 0.0104 meter. I hope you don't have any confusion in this one. In this, we are talking about the length. We are not talking about the area. We are not talking about the volume here. Okay. So keep that thing in mind. And we are converting millimeters to meters here. I hope this is clear. Then comes, okay, the last question for today. Now it says, a Perspex container has 6 centimeter square base and contains water to a height of 7 centimeter. Calculate the volume of the water. Okay, so volume of water is 6 into 6 into 7, which is 252 centimeter cube. Now in the B part, see, it says a stone is lowered into water. So what happens? You bring a stone and as soon as you put it in the water, what will happen? The level of the water, it will rise. And let us say now it is somewhere here, which is given to be 9 centimeters. So what will be the volume now? They have said that, okay, height increases to 9 centimeter, but see the base, that is same. So what will be the new volume? New volume would be 6 into 6 into 9. That comes out to be 324 centimeter cube. So what will be the volume of this stone? It will be the difference between these two volumes. So volume of stone is equals to 324 minus 252, which comes out to be 72 centimeter cube. So the volume of stone is 72 centimeter cube. This type of question is very important, and yeah, I hope this question is clear. Well, that was it for today. I hope the lecture was useful. If you liked the session and you were able to understand it, do support us by subscribing to the channel and liking the video and sharing it with your friends. I'll see you in the next lesson.